So AI-ready platform, scaling teams without scaling cost. So once upon a time, there was a user, just like all of us, who wanted to create a platform. Very simple. They go to a cloud or bare metal, procure some hardware, and install Kubernetes on top of that, creates a node pool, and then run their microservices application. So pretty cool, right? Are we missing something? Obviously, we are missing something because AI is the theme, right? So everyone now wants to run their AI applications, and for that, they need GPUs. Okay, the platform engineer, the user, is very intelligent, so he just installs the NVIDIA GPU operator. Wait, what is that? So NVIDIA GPU operator is basically doing, in Kubernetes, there's a concept of device plugins, and NVIDIA GPU operator makes sure that your GPUs are available for your pods that are running on the Kubernetes clusters. It makes them discoverable. So far, so good. But we were here to talk about platform for teams. So what about that? Okay, well, standard stuff that there are two teams who need two separate Kubernetes clusters with GPUs, so they repeat the same process and give them out. Well, it's not so efficient because it's massive cost, and you have limited, if you are on bare metal, you have limited capacity. So what do you do next? But still, everyone needs a cluster. So should we go namespaces? One of the things that you can do is you can have a single cluster, multiple namespaces. Yes, it works for some of the use cases, but the thing is not all resources in Kubernetes are namespace scope. For example, you have controllers. So how do you install different type of controllers or different versions of controllers onto the cluster with different namespaces? Also, there is the concept of noisy neighbor problem. Let's say there's a team A that creates 3,000 secrets, and team B is now starving of the etcd operations because it is logged in by team A. So that's a noisy neighbor kind of problem. So this is where the user discovers a solution called vCluster. vCluster is basically an open source tool to create virtual Kubernetes clusters on top of Kubernetes. Now here, every virtual cluster or every team gets a virtual cluster, and every virtual cluster gets a control plane. So that particular control plane pod is running on the host cluster. So whenever a user interacts with the Kubernetes cluster, the virtual cluster that they are getting, they are interacting with the API server of the virtual cluster and not the host cluster. So you get the noisy neighbor problem resolved over there. And also, since it's a fully CNCF certified Kubernetes cluster that you get out of the box, you will be able to create any type of Kubernetes control, like install any Kubernetes controller on top of that. So this is how the solution looks like now. So you have bare metal, you have Kubernetes, you have a single cluster with all the node pool of CPU, GPU, and then every team gets its own virtual cluster. What about auto scaling? We had that as well in mind, right? Well, pretty simple. Just use Karpenter, because Karpenter is industry standard for your auto-scaling needs, auto-scaling workloads. But one of the key things with Karpenter is that it doesn't work with all the Kubernetes distributions, all the Kubernetes environments. Yes, it works very natively with EKS, but what about other Kubernetes provider? What about bare metal? Karpenter doesn't work with bare metal. So this is where vCluster introduced recently in 0.28 version called vCluster Auto Nodes. Now, with vCluster Auto Nodes, you get Karpenter baked in. So what that means is we got two major features. One is the new tenancy mode called private node. So now you can have a hosted control plane apart from what I showed you earlier, and you can attach number of nodes to that particular hosted control plane. On top of that, you can have the auto nodes enabled that has Karpenter baked in. And when you have Karpenter baked in, automatically it will remove the nodes and add the number of nodes based on the requirement. So this is how it looks like. You have auto node enabled. So this particular setup, the platform engineer is happy. It created got the bare metal hardware, created a single Kubernetes cluster. And now when the Kubernetes, the GPU node is not used by team A of the virtual cluster, it gets released and it gets attached to another cluster using the auto node feature. So, and you can create, as long as there is a Terraform provider, you can use auto node. So, and Terraform provider is available for all the stuff which is out there. So maximum resource utilization, it works for teams, it's a cost-effective solution. Meet us at the booth. We have a booth outside vCluster. Happy to chat more about that. Throughout the KubeCon, we have a few sessions that you can attend. I, along with Daniel from LearnCube, wrote a book on the GPU platforms, and you can download the e-copy of that for free. There will be a book signing as well. I'll even get to see the first hard copy myself for the first time over here. But you can download that for free over here. And thank you. Enjoy the rest of the KubeCon. We are happy to sponsor Platform Engineering Day. Happy to see so many people out there. Would love to chat with all of you outside the booth. Thank you. I think I'm right on time because I rehearsed it. The first talk I ever rehearsed that I have to finish it in 5 minutes. Thank you all.